digital I/O device port of Arduino in detail, how it is the hardware connections, those things we will discuss. We're able to see the circuit. Okay, let's first see. There is some. Let me have an objective. Um, here, the objective is to perform I2C communication. In Tinkercad, the I2C devices are not available, like gyroscope or touch sensor or some other sensors with I2C standard or communication protocol based one is not available in this. So what we decided is to make I2C communication between two Arduino and explain or study the operation. Okay. So here one node will be the master, another one will be the slave. As we discussed in the theory part, a small recap of your theory. I2C is synchronous serial communication, and here we use to interface with various sensors, and it has three wires. One is serial data, serial clock, and a ground line. These three are there, and pull-up resistors have to be connected for data and clock. And here we can have multiple masters and multiple slaves are there. So each slave will have their own address. Like here, master won't have address, but all the slave will have the address. Slave devices will have specific address. The protocol, data format, start bit, slave address, acknowledgement from the slave, and the internal register of the slave, and acknowledgement from the slave, either data read or write operation, which is specified over the last bit over here. Either master reads the data from the slave or writes the data into the slave of this specific register, and after that acknowledgement from the slave after ending with the stop bit. So this is a packet transfer between master and slave. So here we have the clock and the SDA, SCL and SDA, two signals, and how they this and all we discussed in the theory. So this is the connection diagram. SDA to the SDA, SCL to SCL. It had to be connected throughout the devices of the network. Here we have two set of I2C pins. One is A4 and A5 in the analog section of Arduino Uno. A4 is the SDA data pin. A5 is the SCL, that is clock pin. And here one more pair of I2C bus is there. So this is the example or the connection diagram we discussed in the theory. Here, these are the three functions. Okay, here what is the important thing we learned is here this hash include wire.h is the header file or the library file which we had to include for I2C function. And I2C operations are begin the transmission, write the data from the master side. These three are the functions used for sending some information to the slave. So it begins, this is for start bit and that information, and end bit or stop bit. So this way we have to pack the information and send. And from the master, if master want to read some data from slave, then request have to be the request function have to be used. Available avail, available function is whenever the data is completely received in the receiver path, then this will check for the data is completely received or not. And read is to access the serial buffer or the actual buffer, I2C buffer, where the data is. So, so this is a small introduction we have or recap of your theory. Here in this, the objective is to, for example, I have a sensor. Assume this potentiometer is a sensor which sends the water level and gives and gives an analog value to this first Arduino Uno 1. This Arduino Uno 1 uh, will convert that analog signal to a digital and send that digital signal through this I2C bus to this another Arduino Uno. And in this Arduino Uno, it is going to read this I2C data and send it to the serial monitor. So you can assume like I have a overhead tank. From the tank, I want to sense the water level, and I want to display that in the ground floor. Okay, this is 2 floors above, and this is sensing the water level in the overhead tank in 2 floors above, and that water level value have to be communicated to the uh, ground floor module where LCD or a monitor is connected. In that, the display will indicate the water level. So, if keeping that as an analogy or a objective, we are going. We have made the hardware connections. This potentiometer connection already, So I just take the middle or the slider part to the A0 pin of Arduino Uno 1. So Arduino Uno 1 is going to be the master device, and Arduino Uno 2 will be the slave device. Here, so what are the things we have to do? We have to interface the sensor first, and we have to establish or make the hardware connection between the master and slave. Here, this A4 is connected to A4, and A5 is connected to A5. So this is blue color one is the data line, and brown one is the clock. SDA, SCL. Both are connected along with the ground wire. Now, how to program it? What does the program should look like? Here in the master side, I have to start and then initialize port serial I2C by buses. I have to initialize this thing. After initializing, I have to read the analog value, read ADC value, and send it to I2C or I2C write. I have to repeat this operation again and again each time after this. This will be the in the sensor part or the master. Here in slave or in the ground floor, or I have to start again. Here also I have to initialize port I2C serial, because I want to send the data whatever I receive in I2C in serial monitor. So I need serial also. So this thing I'm initializing, and I'm sending this to. After initializing, I have to read the I2C value and serial write. Send it in serial. This I have to repeat it again and again, because what initialization will be done in the first part, and after that I have to read the I2C, so that whatever from here the I2C write, when it completes write, this will be completed reading that communication data, that I have to send it to the serial monitor. So I have to repeat this again and again, as this repeats again and again. So this way I have to program. So here in slave, one more thing I have to initialize. I have to if it is master, I don't have to give the address, but I have to give the slave address also. Here I have to include the slave address also. So now we will see here the code for the master. The Arduino one I have to select. Here we have two Arduinos. So programming this Arduino, I have to switch here. So here I have included the hash include wire.h, the I2C bus protocol I have included, and the analog value, whatever the value I read in this pin, I have to store in some variable. So I use analog in as a one variable, and then message is the another variable. This message variable is used to convert this. It's a converted form of analog. So this is going to be a 8-bit information, and ADC, we know it is a 10-bit ADC we have in this at Mega. So if it is 10-bit ADC, then we need an integer to store the data. And the information will vary from 0 to 1000 something. It will vary. Okay, 1K. It is the maximum size. So I, that value cannot be accommodated and sent in this um, I2C bus. So I need to do the mapping part. We know this mapping. This range will be mapped. Sorry, this is the actual range. If this is the actual range, that have to be mapped to the lower range or the higher range. We can map a conversion part. So for that, I need one variable. So message is the variable that will hold the data which is going to be transmitted through I2C. And in pin mode, this I'm in analog pin, so input pin, and here we have to initialize or start the I2C operation, or I2C bus have to be initialized here. So I have to give the wire dot begin. The same way we give the serial begin, here also we have to give the begin for I2C. So serial begin, just to in this node I just want to display uh, a welcome node, that's all, and also want to see what is the value I'm getting in this part. what is the value I'm transmitting I want to see. So I have added few lines for displaying the values. So the first part of this here, read the ADC value. Here I'm reading the ADC value and mapping it to the lower range. So that is the first part. And write the value into the I2C. So for writing the value in I2C, we need to begin the transmission and write the data and end the transmission. When begin the transmission, we have to specify the address of the specific slave. So I'm going to configure this slave with the address as 9. So I give, see, we can give any address, but only thing, it should not overlap with any other standard one. It should not have a conflict with any other slave devices in the same bus. And most of the hardware manufacturer, they hardwire the address. So we have to study the data sheet first, and we have to get the address to access those data. And after that, write the data, what the message we want to send to the I2C, and end the transmission, and again repeat the same too. This is for just debugging purpose. I have added, just for my understanding, I have added a serial communication just to see what is the value in the transmitter side. And if we go for the receiver side, here in the receiver side, again the uh, just to indicate the intents or the value as wait a second. I think this whole thing is itself is not required. Just to it just turn on the LED when this value comes. I'll remove this and we'll see. So what we have done is initialized the port and all the serial and I2C. Here, while initializing I2C, I have to give the address of this device. This device address is 9, so I have given it as 9 here. And here, uh, this is a kind of interrupt whenever there is a data received in the I2C, it will execute this function. So whenever I read a data, whenever I read a I2C data, I want to send it to the serial. Again, go and wait for a data to be read. So that's what we are doing. So it will be in this infinite loop always. So whenever there is nothing to do in this loop, so it will be simply uh, staying there. And whenever a data is read, here it will read the I2C value that using this wire dot read function, and it is stored in a variable X, and it will be displayed in the serial printer in the serial monitor. Okay. The simulation started, and let's go to the first Arduino 1 master, what it is doing. Here it is with the welcome note. Well, welcome note is started, and it is printing the value whatever it had read in the pen in this. So if it is changing, the analog value is getting transmitted. Meanwhile, I am just viewing it for in the serial monitor for a debugging purpose. At the same time, if you go for Arduino 2, which is a slave, in the ground floor, it also reads the same value. The values were getting updated here. How whenever there is a serial I2C data read, it has been copied to the variable x, and then it is printed over here using serial print ln dot sorry, within brackets x. So this is your next experiment. So instead of leaving this loop empty, we will just do something like we will have, if we have uh, okay, I'm not able to get back that value. I will do digital write. Um, LED. Pin number is 13, and I'm going to make it high. And call for a delay for some time, 200 millisecond, and then we'll do the same and we'll turn on. So while this serial communication and I2C communication is being taking place in the background, I want my device to do just simple toggle operation. So the LED will be keep on blinking. So just to add this code, it's not required also. Just while this LED is blinking in the main program through the event handler or interrupt mechanism, this part of my code is getting executed in the background. Each time when I2C data is interrupting my system, it will jump from this core to this, and it will execute this, and it will come back to the place where it left, and that way it goes on. So that's so small demonstration of I2C. And that's all with this session. See you on the next video.